Stefano, thanks for being pressed into a mini tutorial from us. The floor is yours.
Okay, thank you. So I don't know how many of you are interested in the Python bindings. How many of you are using petsc4py? Okay, so this is using or interested. How many of you are already using the bindings? Okay, and I guess the learning curve was quite steep, right? So and how many of you instead are interested in learning and trying to use it? Okay. So, so this is 15 minutes, so it will be, I cannot say much about petsc4py, but, I will try to show you what we have done recently to help new users to understand how to use it. And so we made a huge effort in documenting the code. So so petsc4py has been developed and maintained for almost a decade by a good friend of mine, Lisandro Dalsin, until 2020, when it was basically merged in petsc. So we petsc developers became also maintainers of petsc4py, but all the credits for petsc4py goes to Lisandro and his work. And so the problem with petsc4py is that so petsc is huge. petsc4py is tries to be Pythonic. So it's complicated to have a Pythonic API around a very large library, and the problem with this kind of setting is that the code is very difficult to understand, at least at the beginning. The API, what to use, what not to use, how to use it, also because it's Python, right? So David Ham has this brilliant idea recently to join forces with me, Lisandro, and others. So we call ourselves coding monkeys. So we had coding retreat of 3 days and a half. We basically merged back 30,000 lines of code in petsc, and that is mostly doc strings. So we decided to do it because we knew that this was needed, right? So this is what I wanted to show you now, so that in principle it should be easier for you to approach petsc4py and use it. And the second thing, if I have time, trying to building on the online documentation stuff that we put together, I will show you something that is here in this repo that shows you, those are very small examples, but give you an idea of what the things that you can do with petsc4py, okay? So I will start with the docs. So this is the location of the documents here. And if you click on it, you'll get the old version of the docs. So those docs, they are complete in the sense that they list all the API, but the functions. But the problem with those is that we don't know really. This is the document for the entire class here. So these are the doc string for the class, and we really don't know what the things are doing, what's the input, what's the output. And so what we did is based. This is epidoc, if you're familiar with Python. So what we did, so instead of on release we go to main, what we did is that we based the documentation on Sphinx, and using the NumPy style and Napoleon style for the documentation. So here documentation is still work in progress, in the sense that most of the general contents are not yet covered, because it was already quite a huge task to cover the API. But at least this is the structure. So here, if for example you have all the API of petsc, and we made an effort of describing what the equivalent of the shell object in petsc in Python. So this is the math shell in Python, the PC shell in Python, the KSP shell in Python, and so on, so that you can wrap existing Python code and let it used by petsc. So I will first show how the documentation works. So for example, here I show you, I don't know, suppose that you are interested in, I don't know, let's get SNES, okay? So SNES is not basic, is advanced because it has callbacks. So I want, let's look at SNES. So the idea is that we have links to the petsc manual. so that you can always go back and read from the PETSc manual what SNES is if you are at that level of knowledge about PETSc. The C also structure here always point to the C documentation, so that you can always go back to the C documentation if you want. And okay, and that is the description of the class. So if you don't know what is SNES converged reason, you have the C documentation here, and so that you can always jump between Python and C, and this is documented. So we are planning to add also a sort of link to source code that is not there yet, but I coded yesterday. But the way it works, so these are local. So, for example, this is NES compute function, right? So you give X as an input. You want the output in a vector. The return type is none, for example, and here is the C also for related a related function in petsc4py. C also for the C API. And we added also a link now that it will be, I still have to understand how to do it better, but the idea is that with the link, you go back to the Cython implementation of the function. If you really want to know what actually PETSc is doing, petsc4py is doing, and this is the Cython implementation, so this is basically calling the usual C API in some way, okay? At least, in this way, you can navigate a little bit more and understand what's going on. And so, for example, here, compute Jacobian, here, you see it gets a vector as an input. So this is all based on typing in Python. So if you don't know what is a vec, you click here and you go to the vec class, right? And so those are specifications. For example, in this case, this is Python, so this is an optional argument. P can be either a math or none. If you click on none, you get none from. This is the nice thing about things, right? So that you get interoperability with all the other packages that you want. So, for example, setting the size of a vector, it was quite obscure before, even setting a size. So if you do vec set size. So now, size has a specification here. That what is size? Okay, size can be either an int or a tuple of ints. So that in principle, all that you need to know about how to use petsc4py can be, you can see what to do. And okay, so there are not all the classes are covered. Most of them you can look at here. The classes that here they don't have a basic doc string that documents the base class. They're still to do. So, but there are not so many. So, if you Jakob want to do device, it's here for you. And so log is there, but this is missing. But the basic Python, the basic PETSc object in Python, it's not documented, but it's not important. But you see preconditioners are there, SF, even quadrature rules, for example, of scatter or tau. Everything else is covered. Okay. And for example, in the case of SNES, if you go to compute function, let's say so for example, compute objective, it computes the objective function. What does, it uses the function that you set as an objective. And here it tells you, how the objective look like. Because if you look here, this is the alias, the callable, this function has to be a callable in Python and has to take a SNES and a vec and a none. This is Python syntax, so that you can what the callback should look like. Okay. Question or something that you want to know better about this?
Any questions out there about the petsc4py interface?
No? Okay. So, yeah, yes. So for the tutorials, this is the repo that I was, that I put together for a couple of courses that I gave that has other stuff in it. But I guess it's, if you are a newbie in petsc4py, it's kind of interesting to see, to see the Python, there are codes that have the C implementation and the Python implementation, and you can see the difference. So we are for example, the new here overview. So this new, so we have already we ported one demo from that repo here, so that here in principle you know how to do Poisson in 2D, and it's explained why you want to do this, for what reason, and feedbacks are always welcome if something is not clear. But the idea is that we really spent a lot of time trying to be as educational as possible, right? But for example, the only documented demo we have is Poisson in 2D, okay? Because we didn't have time to do others, but they can be found elsewhere. So for example, here we had the specification of how to work with the shell objects in Python. So I guess if you want to have mud shell, you want to prescribe the action of the operator on a vector, and those are the matrix type in Python that does that. And here we explain how the class should look like, so that you can wrap Python code and let it run by PETSc. And those things, they also have examples here. So for example, in this class, this is a simple Poisson 2D class that uses a DMDA. And the application of the matrix is going through the DMDA and do the usual Poisson application. The thing is that this operation is done on the Python side. So here you can put whatever you want, right? So one of the examples here that I have is getting one of the examples from Leuchter about spectral methods. So this compute eigenvalues of high order discretized Laplacian with Chebyshev polynomials, spectral methods. And here, for example, I have the only thing that I have to do is that I want to say how the matrix applies on a given vector and gives the output. And this is, like as you can see, this is NumPy stuff. And in this example, I create a matrix which is of type Python that has an instance of this class as a context, and I feed the matrix to SLAPC, and I compute the eigenvalues. And I guess I can also run it. Right, so you can get, those are the eigenvectors, the first 4 eigenvectors. This is the third, the second, anyway, but these are the eigenvalues, so it works. But you can always do something like, this is PETSc, so you can do EPS monitor and get the monitoring of the SLAPC solver. You can do all everything that you want here. And in these examples, there are also, if you are interested, there are also examples on how to use TS, so ODE solvers. So for example, here is the usual Lotka-Volterra example, very, very simple. And in this test, in this example, we also use the shell ODE solver in PETSc, which is basically calling ODE int from SciPy. So, if your solver was, use ODE int from SciPy, you can always wrap it, in a class and have PETSc call this specific solver here. And this is, as you can see, this is the API that you want to implement for the ODE solver in PETSc, and this is calling ODE int. Same for here. Oh, here this is another example using a minimization problem in Tau doing image denoising. And I just chose it because it's a nice example about using Python packages, right? So that you do image read and gradients on an image, and it's nice because it's Python, and it does what it's supposed to do, I hope.
It's really nice to see the connection to all the different packages. And so this is also the technology that was underlying what Hong presented yesterday, so that's what let him connect to PyTorch and use the automatic differentiation there. And Stefano, I understand you're also doing some work on machine learning methods and comparing them to classical methods. Are you doing this through petsc4py?
Interfacing with these machine learning tools is not that hard. So, because I plan to, for example, Hong added the DLPack interface, which is what you need, to interface with most of them. I was planning to add the CUDA array interface that we don't have to work with other HPC stuff. But it's not very hard. The problem is that you always have to copy back and forth because it's safe to do that, because some of the packages like JAX, for them arrays are throwaway memory. So you have to be careful on a few things, but it's using this class. I use these classes. I use the mathvec for the Hessian. I've wrapped the Hessian of them in a math, and that's it.
That's great.
Yeah.
And so we'll be able to find more material on the examples repo that you shared, and we'll eventually get the slides that you shared.
The slide is one slide, but yes.
Just sent them right now.
Yes.
All right. Thank you so much, Stefano. Let's give him a round of applause.